to talk about trigonometric identities, and my first is a definition. If I have two functions, f and g, so we say that they are identically equal if f of x equals g of x for all x, for which both the functions are defined. So if there's a place where one isn't defined, then we know that they can't be identically equal anyway. So if I have an equation, f of x equals g of x, this equation is known as an identity. Okay, and so we had some identities we used when we were solving the trig equations, like cosecant theta equals 1 over sine theta. That's an identity because they're equal. They mean the same thing, right? Or cosine squared theta plus sine squared theta equals 1. That's an identity because the left-hand side equals the right-hand side. What we're going to do now is prove that they're true. So I have two basic rules. The first one is that you cannot move values across the equal sign. And so I like to equate that to, if you've seen the movie Lord of the Rings, when Gandalf stands at the bridge and he says to the monster, "You shall not pass." That's how I feel about the line between the two equal signs, and I'll show you when we do some examples. Okay, and so this similarly, it's written in different ways. It's expressions on the left-hand side remain on the left, and similarly, those on the right-hand side remain on the right. So those are my equations. So I want to talk about some guidelines that we use when we solve. So my guidelines are, usually what you want to do is start on the side with a more complicated expression. So I want to start on the side with the more complicated expression. Sorry for it's moving around a little bit. Simplify your fractions. Simplify your fractions. So that means find a common denominator. Try rewriting as sine and cosine. Always keep your goal in mind as you do your manipulations. And then it's okay to work on both sides of the equation. So those are the guidelines we're going to use, and we're going to solve some identities.